The observer pattern involves an object known as the subject maintaining a list of dependent objects called observers and notifying them automatically of any state changes. So that may not make too much sense to you, so let's go through an example to learn the observer pattern. So here we have an Excel document with two spreadsheets, spreadsheet 1 and spreadsheet 2. And in spreadsheet 1 we have a data source, which is essentially just a two-column table with city in the left-hand column and number of dogs in each of those cities in the right-hand column. And then we also have a bar chart with dogs on the y-axis and the city name on the x-axis. And this bar chart is essentially built from this data source. And then in spreadsheet 2 we have a sum. So we have one of the cells is basically summing up the number of dogs to get the total number of dogs in all of the cities. So let's first of all come up with a naive or sort of obvious solution to this problem. So we have a data source object which has a list of observers. So the observers are going to be sheet 2, so spreadsheet 2, which is calculating the total number of dogs, and we have a bar chart which is producing a bar chart from the data source. So here we also have the values of the data source and a getter and setter for getting and setting the values in the data source. Now the problem with this solution is that we have tight coupling to the concrete observer objects, which are spreadsheet 2 and the bar chart, meaning that we need conditional statements to check the object type before we actually update the observers. So this will probably make a lot more sense as we implement this solution in code, so let's do that. So first of all, let's create a new folder for the observer pattern. And what we will do in here, first of all, is create our spreadsheet 2 class. So our sheet 2 will have a field for storing the total. It will also have a getter, which just returns the total. And then we'll have a method for actually calculating the total. And this will take a list of integers. And we'll keep track of the sum in a variable called sum, and we'll initialize that to 0. And what we're going to do is we're going to loop through each value in this values list. And we're going to add it to this sum variable. So we can do sum plus equals value. And then let's just log what the value is. And return the total at the end. Okay, so that's everything we need in this spreadsheet 2 class. So let's now create our bar chart class. And in here we're going to have a single method called render. And this is going to take the list of integer values from the data source. And we're just going to keep it simple and log rendering bar chart. Okay, so obviously if this was a proper bar chart, we'd need to pass in probably an object with keys and values, or some sort of dictionary where we have the key as maybe the city and the value as the value. But we're just going to keep things simple for now and just pass a list of integers because we're not actually going to be drawing a bar chart. So finally, we can create our data source class, and this class is going to store a list of the dependent objects, or essentially the observers that rely on the data source, and those being sheet 2 and bar chart, so that when the values in the data source are changed, the data source can update those dependent objects. So let's create the data source, and in here we're going to have a list of values. So this is kind of analogous to our number of dogs in each of the cities, basically. And we'll create a new list of integers, and we'll also create a list of dependent objects, or our observer objects. And these are just going to be sort of type objects. We're not going to specify the exact type of object, so that we can pass in either bar charts or sheet 2s or any object that needs to be updated when the data source values are changed. So we're going to call this dependents. We could also call it observers, but dependents will do for now. And we'll just initialize that to a list of objects. So next up, we're going to create a getter for the values, so that the other objects can get the values. And we just return the values there. And then we'll also create a setter method called setValues. And this needs to be a list of integers. And we just set values equal to values. Now in here, whenever we update these values, we also need to notify our bar chart and sheet 2, so that the bar chart can re-render itself with the new values, and sheet 2 can recalculate the total. So what we're going to do is we are going to loop through all of our dependents, or all of our dependent observer objects. So we can say for dependent in dependents, and this needs to be a for each loop, sorry. And in here we need to check the type of the dependent, the object type. So we can say if dependent is sheet 2, then we can cast the dependent to a sheet 2 object by writing dependent as sheet 2, and this will allow us to recalculate the total. And then in here we need to pass in the new values. Okay, and we also can check if the dependent is a bar chart, and if it is a bar chart, we can then cast the dependent object to a object of type bar chart, and we can call the render method to re-render the bar chart with the new set of values. Okay, so that's actually everything we need to do for this setValues method. But now we also need a way of adding dependents to our data source, so that we can actually control which objects are going to observe this data source. So for that, we can create a method called addDependent. And in here we can pass any object, and we quite simply just add this on to our list. Okay, and we also want to create a method for removing dependents. And in here we can pass the object that we want to remove. And we can call dependent.remove and pass that dependent. Okay, so that's everything that we need in data source. So we have our sheet 2 and bar chart observers, and we also have our data source. So now let's have a look at how we could use this solution in a client. So let's clear this out and create a new data source object. And let's also create our sheet 2 and bar chart observers. And now we need to add these objects to the data source as dependents. So we can call data source dot add dependent and pass in sheet 2. So this can be any object. And we can also add our bar chart. Okay. And then what we can do is we can set some values in the data source. And in here, we're just going to pass a simple list of integers. So we can say 5, 5, 1, 10. And let's actually run the program now to see what we get. So you can see here when we called set values, it has actually updated the total in the sheet 2, and it's the total is 21, which is correct, and it's also re-rendered the bar chart with these new values. So if we then call the set values method again, and we just set the values to say 1, 2, 3, run the program, and we should then get a new total, and we should also get the bar chart re-rendered, which we do. So this is all working perfectly. However, there are some issues with this solution. So can you see what solid principles we are violating? So maybe take 30 seconds or a minute to have a look at the solution that we've just come up with and see if you can spot what solid principles are being violated. And the two of the most obvious principles that we are violating are, first of all, the single responsibility principle, because this data source class actually has two responsibilities. It is storing data, so managing data storage, and it is also managing the dependent observer objects. So it has two reasons to change. And we also are violating the open-close principle, because every time that we create a new observer object, we have to modify data source. So if we create, I don't know, pie chart, we then have to modify data source. We have to come in here and check if the dependent is of type pie chart, and then call the appropriate method to actually update that pie chart with the new values. So we are violating the open-close principle. And this is because we are programming to concrete objects rather than to a generic interface. So how do we solve the issues that we spotted in our last solution? So we were violating the single responsibility principle, and we were also violating the open-close principle. So to solve the single responsibility principle, we could actually create a separate class for managing the dependent observer objects. And to solve the open-close principle, we can ensure that all of our observer objects, so sheet 2 and bar chart in this example, implement a common interface so that they provide consistent methods, allowing us to use polymorphism in the data source class. So it's now time to introduce the observer pattern. So for the observer pattern, we have an abstract class called the subject, and in the subject we have some methods for managing observers. So this is like our separate class for managing the dependent observer objects. And in here we have a method for adding an observer, for removing an observer, and for notifying the observers or updating the observers. We then have our data source class, which manages the values in the data source, as well as a getter and setter for those values. And we can see here that the data source is inheriting the observer methods from this subject class. We then have the subject talking to an observer interface, which has a single update method. And we can see here that the subject is composed of observer objects. So this will store a list of observer objects. Okay, and you can see here that this abstract subject class is coded to an interface and not the concrete observer classes. And as you can see here, we have our two concrete observers, the sheet 2 and bar chart, which implement the observer interface, allowing us to use polymorphism. Okay, because this subject class, when it notifies the observers, doesn't have to check what type of object we're dealing with, because it knows that they are of type observer. It can just call the update method without knowing the specifics. So this actually, this solution now follows the open-close principle, as we can extend our application by adding new observer classes without having to modify the data source class. So for example, tomorrow we may want to add another spreadsheet that finds the average of the data source values, and to do that we can just create a new sheet 3 class that implements observer, and the data class doesn't care, it just talks to the observer interface. And set values in the data source will simply loop through all of its observers and call the update method on each. And this is polymorphic behavior. A different update method will be called depending on the observer, but data source doesn't care, or it doesn't need to know what the specific concrete observers are. Each concrete implementation figures out how to update themselves. So if we have a look at the gang of 4 observer pattern here, we can see that we have the abstract subject class with 3 methods for managing the observers, the list of observers, and we have an attach, detach and notify. So that's basically the same as what we had up here: add, remove and notify, or add, detach and notify. Then we have our observer interface with its update method, and we have our concrete subject and our concrete observers. So very similar to the solution that we have up here. So the observer pattern is also known as the pub and sub pattern, so the publish and subscribe pattern. And the subject, which is the publisher, publishes changes in its state, and the subscribers, or the observers, subscribe to those events. So let's now refactor our code to use the observer pattern. So let's now refactor our code using the observer pattern. So first of all, we're going to create an observer interface, and in here we give it a single method called update, and then we can refactor our concrete observers. So we have bar chart, which needs to implement observer. And we can see here we get a red squiggly line indicating that we have an error because we are not implementing the observer update method. So here we can simply change this method to update, but we still get an error because we are not actually using the same method signature. So if we go into this observer interface, we can see that update doesn't have any parameters. So we need to remove this parameter. But we still need a way of getting the values from the data source. So what we can do, instead of passing them to this update method, we can store a field of type data source and pass the data source object into the constructor whenever we create a new bar chart. Okay, so that's everything we need to do for our bar chart class. So let's now go into our second observer, which is sheet 2. So again, we need to implement the observer interface, and then we also need to implement the methods. So we get an update method here. So what do we need to do in this update method? So I'm just going to move this up a little bit. So let's move it to here. And what we want to do is we want to set the total to the sum of the values. So currently we don't have any way to access the values. So again, let's create a new field for the data source. And we'll pass that via the constructor. And now what we can simply do is set the total field equal to calculate total, and we can pass the values by getting them from the data source object. So here we can just say total is equal to calculate total, and then we can get the values from the data source object, which we have passed into this object. Okay, so that is everything that we need to do for the Sheet 2 class. So now what we can do is we can create our subject class, which is going to be the class that manages observers. So let's create that class. And here we need to first of all create a field for keeping the list of observer objects. Okay, so then we need to add our 3 methods for managing observers. So we need a way of adding observers, removing observers, and also notifying all the observers in the list that our sort of source object has changed. So first of all, let's create the add observer method. And then here we pass the observer that we want to add to the list. And we can just call observers.add observer. And then for the remove observer, and again we pass the observer to this method that we want to remove, and we just call observers.remove, and we pass the observer. Okay, and finally we need a way of, we need a method to notify our observers. So here we can see we're getting a suggestion for each observer in observers, and that's what we need to do. And we can just call observer.update. So we can call observer.update. Okay, so here we can see we are using polymorphism to update the observers. This subject class doesn't need to know anything about the actual specific concrete observers that are in this list. It just needs to know that they are some sort of observer, so that we can then use polymorphism and just call the update method. So this is a nice, flexible, clean, maintainable way of notifying the observer objects, even though they may be even though they are different types of objects. So next we need to refactor our data source class. So in here we no longer are managing the observers, so we can remove this dependence list. And let's see, so we have our getValues method, so we want to keep this, okay, because this is used in our observer, in our concrete observers. And the setValue method can now be cleaned up. So we can see before we were storing a list of just objects, and we had to actually check the type of object and then cast it to the type that it was found to be, so that we can could call the update method on that object. So what we can do now is we can actually get rid of this large block of code and simply just call the notify observers method. But we can't do that yet because we actually haven't inherited the subject class. So let's inherit that. And now we will have all of the methods from this subject class. So we've inherited them, which means that we can just call notify observers. So this is much cleaner. And we also no longer need to have these add and remove methods because this class is no longer managing the observers. So that is much cleaner. So that should be everything that we need to do. So let's now go into the program.cs file and let's change this to observer.goodExample. So let's see, what do we need to do differently here? So we are creating a new data source. So let's see. Let's actually start again here. So we'll say data source equals new data source, and let's create our observers. So we'll create a sheet 2. And actually this should be our good example, sorry. I'm not sure why we are getting an error here. Let's see. So what did we do here? Let's see. So we're using lowercase s here actually, so let's just use a lowercase s. Actually no, we'll change this here to be correct, so let's correct this. So if I use function F2, let's change that to the correct casing, and then come back into program.cs. There we go, the error goes away. So now for sheet 2, this is our first or second observer, I guess. We need to pass the data source object into here. And we also need to create our bar chart class. And again, pass the data source into that object. And let's see, And what did we do here? Let's see. For some reason I decided to not use, not uppercase the second word again. Let's see. Okay, so hopefully that fixes that issue. Okay, there we go. So now we can add our observers to the data source object. So let's do that. Okay, so now if we set the values in the data source, it should then notify our observer objects and cause them to be updated. So let's try that. And we're going to pass an array of values, so 5, 5, 1, and 10. And let's run this program to see if our observers are notified and updated correctly. So here the sum is 21, which is correct, and we are rendering the bar chart with new values. So if we also if we change the values now to 1, 2, 3, so let's see what we get now. We can see that the total is updated correctly and the bar chart is rendered with new values. So this is all working perfectly. So we can see here, let's have a look at how using the observer pattern has improved our solution and made it more flexible and maintainable. So if we look first of all in the data source class, we can see that this is now satisfying the single responsibility principle, because data source is now only managing the values. It is not managing observers. The observers methods and the observer list are all managed by this subject class. Okay, so now this subject class has a sole responsibility for managing observers, and a good advantage of this is that this subject class could now be used for any other class that needs to be observed. So this is a much more flexible and maintainable solution. And the second thing that we've done is, because we are now using an observer interface and forcing all observers to implement this observer interface, we can now use polymorphism inside of our subject class. So we can see here that we can simply call observer.update and treat all observers as though they are the same object without having to check the type of object and then call that correct specific method on the observer. We know that they have an update method because they are implementing the observer interface, and we can just use polymorphism, which makes our solution much more clean and flexible. So we're now going to have a look at the different types of communication styles that can be used when implementing the observer pattern. So beforehand, the observers get notified of a change, but they don't know what has changed. And one solution is to add a parameter to the observer update method. And this is known as a push style of communication, as the subject pushes the changes to the observers. So beforehand, the way that our observers got the values from data source is by actually storing the data source in a field within the class, and then when we need to get the values from data source, we call a method on data source. So a push style communication would be different. So we wouldn't actually store a field for the data source within the observer, and we would actually push the values to this update method. So this update method would have some sort of parameter, and that could be any object or just some sort of generic type for flexibility. So the push style has the advantage that the concrete observers don't depend on or have any knowledge of or coupling to the concrete subject. Okay, so the problem with this solution, with this push style solution, is that what if each observer needs a different set of values? And this is where we could use a pull style of communication, where the observer stores a reference to the concrete subject. Then whenever it's notified of a change, it pulls or queries the data it needs from the concrete subject. And you can see here, this is actually the solution that we used for our example, where we have our concrete observers that keep a reference to the concrete subject. And you can see here, sheet 2 and our bar chart both have a field with reference to the concrete data source object, which is passed in via a constructor. And then whenever it needs any values, it can pull them or query them using this getValues method. So you can see the difference here between push style and pull style. With push style, we are pushing the values to the update method by passing them as arguments, and this means that the concrete observer doesn't need to be coupled to the concrete subject. However, it's not as flexible as the pull style, where the concrete observer keeps a reference to the concrete subject, allowing it to query any of the values that it needs. So again, the concrete observer stores a reference to the concrete subject in pull style, and we give concrete subjects a getValue method so that the concrete observers can get the data that it needs, and this gives us more flexibility. However, we do have coupling here between the concrete classes, but this isn't actually a bad type of coupling. A bad coupling would be between the concrete subject and concrete observer, so if we basically reverse this arrow. And this is because these observers could change in the future, and we may also introduce more observers. And the concrete subject would then have to keep reference to all of the different types of concrete observer. So this would not satisfy the open-close principle, because every time we added a new observer, we would have to update the concrete subject. And we don't want to change our concrete subject class, data source in our example, every time there is a new observer. So in reality, we never have zero coupling in software. What matters the most is the direction of the relationship, and in this case, the direction is okay. So with pull style communication, we pass the concrete subject, the data source, to the observer, just like we did when implementing our observer pattern for our data source with the bar chart and sheet 2 observers.